Okay, so let's try to solve a couple of types of problems in the section equation of lines and planes. First, let's start easy. Line through 2 points. So we want to find parametric equations for the line through the point A, let's see, 2, 1, and minus 2, and the point B, let's say 3, 4, 5. To solve this problem, we go directly to finding a directly vector of the line, which will be a vector on the line. So this will be exactly the vector AB. And the vector AB is obtained by subtracting the corresponding coordinates of B minus the corresponding coordinates of A. So B minus A in a sense. So 3 minus 2, 1. 4 minus 1 is 3. 5 minus 2 is 7. So 1, 3, and 7 are the components of the directing vector of the line. So we call this A, B, C. The equation of the line will be basically x equals to x0 plus at, y equals to y0 plus bt, and z equals to z0 plus ct. In this case, we can take for x0, y0, z0 either one of those 2 points. Let's take 2, 1 minus 2. So x will be 2 plus t, y will be 1 plus 3t, and z will be minus 2 plus 7t. So this will be parametric equation of the line AB. So we have the line, this will be A, this will be B, line will be B, and these are the parametric equations. Okay, second type of problem. What I got here, plane through 3 points. So line through 2 points, plane through 3 points. Of course, those 3 points are supposed not to be collinear. So plane through 3 non-collinear points. Okay, so let's take the point A, 1, 2, 5. The point B, 3 minus 1 minus 2. And the point C, 2, 1, 4. So these are 3 points, A, B, C, and 3D. And we want to find the equation of the plane containing those 3 points. So we look at the triangle ABC. And actually, this is the plane of the triangle ABC. What's the plan for this type of problem? Can it be from the given data? 3 points, we go by subtracting final minus initial to 2 vectors. On 3 points, there is a premise. Then we go to 2 vectors. So those 2 vectors will be AB vector and AC vector. Then, if we take their cross product, we get a normal vector of the plane. This will be ABC, which will be AB cross AB vector cross AC vector. Once we got AB vector cross AC vector, let's call it ABC. We use the point vector formula for lines, then we use a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals to 0. When x0, y0 is 0, would be either one of those 3 points. Okay, so let's try to solve it. What's AB vector? AB vector is B minus A, symbolically speaking. B minus A is, so x coordinate of B minus x coordinate of A, y of B minus y of A, and z of B minus z of A. So 3 minus 1 is 2, minus 3, and minus 7. What about AC? AC will be C minus A. So 1, minus 1, and minus 1. So 2 minus 3 minus 7 is AB vector. 1 minus 1 minus 1 will be AC vector. From these two, we'll get, let's get a normal vector. Let's move here. From this one, we get AB cross AC is terminal IJK 2 minus 3 minus 7, and then 1 minus 1 minus 1. This will be left angle, right angle. So let's see what we get here. Remove from the column, so I'll get 3 minus 7, it will be minus 4. J is minus 2 minus 2 plus 7, which will be 5, but in the position marker it's a minus 5. And finally, remove the lone column of k, we get minus 2 plus 3, that will be a 1. So a normal vector in the plane will be minus 4, minus 5, and 1. So this will be ABC in our previous notation. ABC, the components of a normal vector. Now, the equation of the plane will be a times x minus x0 plus b times y minus y0 plus c times z minus 0 equals to 0. For x0, y0, 0, you can pick any of those points. Let's pick a. So x0 equals to 1, y0 equals to 2, and z0 equals to 5. And a is minus 4, b is minus 5, c equals to 1. So we'll get a, which will be minus 4 times x minus x0. So minus 4 times x minus 1. Then minus 5 times z minus 2. And finally, plus 1 times, minus 5 times y minus 2. So minus a times x minus x0, b times y minus y0, plus c times z minus z0. So z minus 5. x0, y0, 0. So, okay, equals to 0. Open a parenthesis, we get minus 4x minus 5y plus z. Then if you open this one, plus 4 plus 10, then minus 5 equals to 0. So that means minus 4x minus 5y plus z equals to minus 9. And if you have a few minuses multiplied minus 1 left and right, so this will be equivalent to 4x plus 5y minus z equals to 9. There's a plane through those 3 non-collinear points, A, B, and C. So 4x plus 5y minus z equals to 9. Okay, that's the second type of problem. So let's do others. Okay, number 3. The third type of problem. That's easier. Plane through a point that is parallel to a given plane. Plane through a given point that is parallel to a given plane. Okay, so let's see. Plane through the point A, let's call it 1, 2, 3, and parallel to the plane x plus 2y plus 2z equals to 0. So what's the equation of the plane passing through the point 1, 2, 3 that is parallel to the plane of equation x plus 2y plus 2z equals to 0? Now, because the plane we are looking for, so there's the plane x plus 2y plus 2z equals to 0. And there's the point 1, 2, 3. We can easily verify that this point is not in this plane because the coordinates of the point A do not satisfy the equation of this plane. So, we are looking for a plane passing through, let's make it different color, passing through this point 1, 2, 3, that is parallel to the plane x plus y plus 2z equals to 0. Being parallel means the equation of this plane still has the same, having the same normal vector due to the fact they are parallel. Parallel planes could be considered the same normal vector. So 1, 2, and 2. So still the same beginning in the equation of the plane for this one. So we get x plus 2y plus 2z equals to something else, different. We have to find out the constant d such that this plane contains the point 1, 2, 3. So we need to find d. We need to find d such that the plane x plus 2y plus 2z equals to d. If we don't say anything, x plus 2y plus 2z equals to d is a general equation of a plane parallel to x plus 2y plus 2z equals to 0. But we need to fit d such that this plane contains the point 1, 2, 3. So what do we need to do? We have to set x equals to 1, y equals to 2, z equals to 3, so such that this plane contains the point 1, 2, 3. So in this equation, set x equals to 1, y equals to 2, z equals to 3. What do we get? 1 plus 4 plus 6 equals to d. Therefore, d equals to 11. So we solve the problem. The equation of the plane parallel to the plane x plus 2y plus 2z equals to 0 containing the point 1, 2, 3 is x plus 2y plus 2z equals to 11. So this plane x plus 2y plus 2z equals to 11 is parallel to x plus 2y plus 2z equals to 0. Well, that's obvious because they're the same normal vector. But this plane addition passes through the point 1, 2, and 3. There's a second type of possible problem we do in the category equation for lines and planes. Okay. Next. Let's see, what is next? Okay, so next, which is slightly more complicated, but let's see. Plane passing through a given point and also through the line of intersection of two given planes. Plane which passes through the given point, right? That should be given, and containing the line of intersection of two given planes. So, what we are given? We are given a point and two given planes, let's say this one and this one, and the two given planes, let's say that they have a line of intersection F. So this is given, this plane is given, this plane is given. This line L can be found, and then this point is given. So we need to find the equation of the plane passing through a given point, so passing through this one, and through this line of intersection of two given planes. Clearly, through a point which is hopefully will be experienced with this line, through this point and this line, there is exactly one plane passing through point on the line. So that's our objective, find the equation of the plane passing through a given point and the line of intersection between two given planes. Okay, let's take a numerical example to see how it works. The plane, so plane through the point A with coordinates 1, 1, and 1, and containing the line of intersection between the planes, well, x plus 3y plus z equals to 1, and 2x plus 7y minus z equals to 1. 2x plus 7y minus z equals to 1. So one of the two planes will be, this plane will be x plus 3y plus z equals to 1. And the other plane, this one is 2x plus 7y minus z equals to 1. So what's the plan here? One possibility is there is not a unique way to solve this problem, but one possibility is that once we got two equations, it is possible in a pretty straightforward way to find 2 points on the line of intersection. So plane, there's the plane. Use the equation of the two planes, so use those two equations to find 2 points on the line of intersection. This point is A, 1, 1, 1. So we already got 1 point. We need to find 2 more points. We need to find a point B and a point C. To find 2 points on the line L. 2 points. Let's call them B and C on the line of intersection L. Okay, line L is the line of intersection between this plane and this plane. So how to find 2 points? One possibility is to set z equals to some special value and solve for, once we set z equals to a numerical value, we got 2 equations in x and y. In principle, we'll be able to solve for x and y. So let's set z equals to 0 first. Read again those 2 equations. If z equals to 0, we get x plus 3y equals to 1, then 2x plus 7y equals to 1. Now we have to solve for x and y. One possibility, quickly multiply the first equation by minus 2, add the second one. So in this way I get quickly y, so I get y equals to minus 1. Then going back to the first equation, y equals to minus 1, therefore x equals to 4. So since z equals to 0, the first point B is the point x, y, z. So 4 minus 1 and 0. So we got the second point. So the first point on the plane we are looking for is A, 1, 1, 1. The second point on the plane we are looking for is the point B, 4 minus 1 and 0. To find the third point, set z equals to another value. Set z equals to 1, for example. In which case, the two equations of the two planes, they become x plus 3y equals to 0. And then 2x plus 7y equals to 2. Okay, again, let's solve for x and y. Proceeding exactly as before, we get y equals to 2 and x equals to minus 6. Okay, so the third point is C with coordinates minus 6, 2, and Z is 1. So how many points on this plane shown here we got so far? We got A, 1, 1, 1. We got, let's add A, 1, 1, 1. That's given. We didn't do anything to find A. A is given. A is 1, 1, 1. B is 1 point on the line. C is another point on the line. So what we need to do is find the equation of the plane ABC. As before, from 3 points we go to 2 vectors, and then we get then take their cross product to get a normal vector plane, and then the equation of the plane will be doable in an instant. So from A, B, and C, A is given and B and C are calculated. Let's calculate AB vector. Is B minus A. So 3 minus 2 and minus 1. 3 minus 2 minus 1. Okay, AC vector. C minus A. So minus 7, 1, and 0. These are two non-collinear vectors in the plane to be calculated. So to find a normal vector, we get AB cross AC. And what will be this? IJK, 3 minus 2 minus 1, minus 7, 1, 0. And this will be a left angle, right angle, so we have to write it down in this format. So we'll get component of I will be 1. Then we get minus, so we get minus 7, but position of marker we get 7. Then for K we get 3 minus 14 is minus 11. 1, 7, and minus 11. And these three components are the components of a normal vector plane. Normal vector to the plane ABC. Okay, so then use the formula A times, so then use A times A minus 3, 0, plus B times Y minus Y, 0, plus C times C minus Z, 0, equals to 0. A, B, C are this, A, B, and C. A0 by 0, 0 is one of those 3 points. Let's take, because it's a nicer 4, A, point A is 1, 1, 1. So 1 times x minus 1 plus 7 times y minus 1 minus 11 times z minus 1 equals to 0. So open the parentheses, I get x plus 7y minus 11z, x plus 7y minus 11z equals to, move everything to the right, we calculate so minus 11 plus 7 plus 1 minus 11 plus 8 is minus 3. So this will be the equation of the plane passing through the point A 1, 1, 1 and containing the line of intersection between those two planes, two given planes.